Alright, we're going to present on the topic understanding density. Subtopic measuring mass and volume and experimenting sink or float objects. So here are my group members. Group 3 members, TVET. We have Sue Walker, Joanna Thomas, Navita Isaacs, Naomi Granis, Casilda Henry, Julian Brown, Janixa Larson, Dwight Thompson, and Naomi Paul. I will be defining the term density and explaining the formula for density. So, what is density? Density is simply how much stuff, which is mass, fits into how much space, which is the volume. So the formula that we use is mass divided by volume, which can be expressed as density equals to mass divided by volume. So mass is how heavy something is and can be measured in grams, which is G, or kilograms, which is the kg. And volume is measured in milliliters or cubic centimeters. So here is the comparison of density in regular shapes and irregular shapes. So regular shapes such as cubes, spheres, cylinders, and rectangular blocks are quite straightforward and easy to calculate the volume using formula. No special equipment is needed. So on the other hand, irregular shapes such as fruits, stones, sponges, and piece of glass lacks uniformity, meaning their sides and angles are not equal, and the volume cannot be calculated with formulas. Instead, we use the water displacement. Here is an illustration showing how density can be visualized in various shapes. These are some examples of regular shapes. As you can see, there's a cube, a sphere, and a cylinder. So by looking at these objects, particles within these objects, you can identify the density for each regular shapes. So the cube particles are spaced far apart, which represent low density. The cylinder has a reasonable space particles indicating medium density, and the sphere is tightly packed with particles, which can be high density. Yes, so here is another diagram of irregular shapes. As you can see, there is a cork, a wood, and a metal in a beaker there. So density can be seen through how the irregular shapes behave in water, whether they sink or float. So the objects that sink has greater density and objects that float has less density. And here is another example showing an illustration of a metal ball and a wooden ball. It is clearly shown that the metal ball sinks and the wooden ball floats, even though both have the same volume. So the metal ball is denser and has more mass packed into the same space, while the wooden ball has less density. So we had to do an experiment, and this is our experiment section to see or to calculate the densities. So our aim was to measure mass and volume of various objects and calculate their densities. So the materials we used were fruit, which is the lemon, piece of glass, nail, rock, and cork. So our apparatus that we use were water, measuring cylinder, digital scale, beaker, and notebook. So here is our procedure. Measuring volume. The first step that we did was to gather all the materials for the experiment, and you can see it there. Then water was poured into the beaker at 400 milliliters and the measuring cylinder at 75 milliliters. So we used both the beaker to measure the lemon, and we used this measuring cylinder for measuring piece of glass, nail, rock, and cork. So a lemon was placed gently into the beaker and the volume was recorded. Secondly, a piece of glass was placed into a measuring cylinder and the volume was also recorded. So the same methods was applied using a measuring cylinder for nail, rock, and cork. Looking at how these materials behaved in water, their densities were observed. So for measuring mass, we use a digital scale where we had to measure or weigh all the 5 materials that were identified, and we had to record their mass. So here is our observation, which are these 5 materials here, their mass, their volume, and their density. And we had to identify whether the objects sink or float and write if they are low density or high density. So here is our observation that we got from the experiment. So these are our photos here that were taken during the experiment. My colleagues and I did the experiment here. And here as well. So here is a short video of what we did during the experiment. So the lemon was placed in there, into the beaker, followed by a piece of wood. So instead of this, a piece of wood, we had to use a cork. So this was out, but we just show what we did. So we prefer to write the mass and volume of a cork. So we had these nails on the scale and the other materials that were identified. So in conclusion, we can say that density is mass per unit volume, and regular shapes use formulas, and irregular shapes use water displacement. So objects with higher density sinks, and objects with lower density floats. So understanding density helps explain properties of materials in everyday life. So this is the end of our presentation, and we work as a team here to complete this assignment. Thank you.